Good morning, everybody. So sensors to service, and my remit is to weave in technology, business models, go-to-market, and just for a little bit of spice, AI. So we could do this all day. And with this panel, I would love to do that. So we're going to, what we're going to do is, I've got this great panel up here. We have everybody from startups to some of the world's largest companies. We're represented by 4 countries on the panel here. So let's start with my colleague from Hexagon, Burkhard Boeckem. Innovation across sensors and 3D computing has revolutionized and enriched reality capture to being near real time. How does this impact the value of geospatial technology in terms of its productivity and expand its market economy?
Thank you so much, Ron, and welcome everyone. A pleasure to be here. My name is Burkhard Boeckem, and I'm the CTO of the Hexagon Group. I'm with Hexagon and Leica Geosystems. I came in 2005 through the Leica Geosystems acquisition of Hexagon. Answering your question, innovation in sensors. What do I see? What is basically the blueprint and the idea? Sensor fusion is very important to me, and you see all the products that we brought to the market in the last year. Even if it's an airborne imaging system, it's not just an imaging system. It's always the combination of imaging sensors, LiDARs, IMU, GNSS technology brought together in one house. When we talk of reality capture, when we talk, for example, of tripod static reality capture, it's a LiDAR, it's multiple cameras, it's even an IMU to do basically visual inertial system when you basically transfer it from one location to another, that you don't have to relocate this. And this is just 2 examples out of many. So sensor fusion is super important here. And then basically computing at the edge that benefits from reducing the data, makes assets and analytics and insights to data much, much faster. It shortens your workflow, and you can decide whether you process something at the edge or in the cloud. And then basically the workflows lead to the product, to the insights, to the analytics, to the objects and the products that you want to retrieve. And this is then finally shared via cloud technology, and cloud technology is important, furthermore, in the geospatial world. And if it's all nicely connected with each other, if we get the ease of use in the equation, that's why also our tech line since a few years has been empowering an autonomous and sustainable future. That's why autonomy plays a big role, and this is also through the help of AI.
Next up, Motoyuki Arai. Earth observation sensors and thematic constellations have been adding different types of data to geospatial data ecosystems from space. How do you see the value of Earth observation as a service enhancing productivity and market opportunity of the space industry?
Okay, thank you for the introduction. I'm Motoyuki Arai, CEO and founder of Synspective. I think the Earth observation data's essential value is it has 2 types of essential value. So first one is the coverage, including the unfocused area. So this point is very good for the collaboration with the ground settled sensors. So the coverage, including the unfocused area, and robustness of the sensor itself. So these are the essential value of the constellation, I think, from the vision data.
Next up is Geert De Coensel. Merkator is a software company developing digital twins for the telecom and energy sector. What type of sensors or devices did you identify for managing underground fiber infrastructure specifically, and how does it contribute to moving to a real-time view of the network status?
My name is Geert De Coensel. I created Merkator now 14 years ago. We started as a services company and gradually moved into the software arena. And it led to 2 unique products. One is a digital permitting product. And the second one, it's where we enter into the digital twin arena. The third solution is actually a data product. We We claim to have the best address database of Belgium. It's a data solution, not a software solution. Now coming back on the digital twin, yeah, it's called Marlin the Beast. It's like a fish, it's under the surface, you don't see it. We have the ambition to manage a fiber network. And there are actually two components in a fiber network. You have the physical assets. They call it passive devices. They don't have any intelligence. There is no sensor attached to it. So it makes it very difficult to monitor it. So we said a couple of years ago, those cables and ducts are connected to something. It's called the active devices. And we like to call it super sensors, actually. So what we do is we probe the network. We discover the network, and in, like, let's say 1 hour, we have a complete view of all the light paths of, yeah, on a nationwide of the network. And that we bring then together with the physical part. And it was astonishing that in the first customers where we had that ambition, the data quality was less than 50%. It was really, yeah, shocking. But we can use the tool now to augment the quality. And gradually we move to 70, 80, and okay, the ambition is to really have an operational asset management system. So it's 99, and 99 is sometimes not enough. But by connecting to those devices that make the network, yeah, we are really successful, and the market likes it. Yeah, thanks for listening.
Next up is going to be Thomas Escobar from Google Maps. Your question. Google Maps is one of the largest consumers of reality capture across all platforms. As someone who is responsible for Google Maps product management, what's your opinion on innovations in the field of reality capture and its value for Google Maps and subsequently your end users, all of us?
And so when you think of Google, we really have three primary geospatial use cases. The first one is navigation, getting people from point A to point B. The next is place understanding, which is understanding of a business, where it is, its offerings, its hours. And then there's area understanding. So when people want to go to a place for the first time, they need to orient themselves. And arguably we've been doing reality capture for a very long time, for 20 years. Now, what we've really seen evolving has not just been how users are using that, we'll talk a bit about that, but also who's consuming these maps. So many people here obviously are working with, for instance, automobile OEMs, and an autonomous vehicle, it's not enough to just show them a fixed width road. They want to know the exact width of the road. They want to know the slope, the elevation, all the markings on that road. For professional drivers, if you're a rideshare driver or delivery, it's no longer enough for them to know that that building existed. They want to know exactly where the entrance is. They want to know exactly where to park. And even the average user who drives now, the expectation is you're going to get lane by lane navigation. And so we now have effectively much, much more sophisticated users and customers who still have an expectation that our map is going to be not very overwhelming for them. So when we talk about reality capture and we talk about digital twins, while as before we do this kind of feature by feature, now we have to do so much more of this. It's multimodal. We're bringing in satellite, aerial, street view cars, third-party data sets, structured data sets. We have to do more of that pose, that localization upstream. We have to do more of that alignment upstream. We effectively have to build a 3D model and then derive different versions of a simplified 2D model from that. And what we found is that it's far easier actually to derive a 2D simplified view and multiple views of that real world from a highly detailed 3D model than it is to go from a 2D model and build that up into a really complex 3D one.
Next up is Joseph Seppi from Woolpert. And Joseph, your question is going to be, Woolpert is a leading geospatial company that is in the business of reality capture. How do you see innovations across sensors and AI machine learning helping you to harmonize data and integrate workflows with the solutions?
Sensors, autonomy, and AI are three significant areas where Woolpert makes investments. So reality capture starts with exquisite data, and that leads to exquisite mapping and exquisite analytics. So while we excel in these areas, we depend on our suppliers, our subcontractors, our partners, and our customers, most of all, to get the best solution. No one really does it alone. And to end with, sensors and tightly coupled software can encapsulate decades or centuries of human knowledge, and the sensor and the software that we use is really everything. Harmonizing that, back to your question, is critical. So thank you.
So, Thomas, we'll work backward. A little bit about that, my question around the next generation of geospatial professionals. You know, quite frankly, as a parent, we get to have discussions about what we do at work as our kids are staring from the back seat at the screen and the map. And thank you for that, because it allows us to talk about what we do for a living. So really, help us bridge from that map to getting them in this room.
You know, it's actually a really tricky thing, because when we look at consumers, in many ways, geolocation is baked into so many products now, but it is in a way that they don't have to really understand that anymore. I think where things become really interesting for professionals and for people who then begin to ask that next question of they want to learn more about the insights around the world is in some ways seeing what the technologies can do, but the other is also just lowering the barrier for that. One of the things that I'm very excited about, and we talked a bit about this yesterday, is what LLMs can do in that particular space. That you can actually turn what has historically required a lot more data science and a lot more programming experience into something in which, like we talk about in the programming world, you know, English is the hot new programming language, and you know, what if natural languages are the hot new GIS languages? I think that's the way to really kind of open it up, where people can then start asking questions that are material to them without having to crawl through glass to answer them.
Okay, we've got some hands. First one I saw was here.
I'm Vikash. I am the founder of Godel Space. My question is for Burkhard. You mentioned about solving real-time insights right on the edge. I was curious about what other use cases are seeing for processing right at the edge. I'm curious to know.
So we're currently building AI chips and a lot of AI into these sensors at the edge. Foremost, also in applications where you directly want to have the result, the insight, and the field. It's necessary. For example, if you're staking out a lot of points, or basically if you're building a production line. Where do you want to go next? And maybe there's a human in the loop that is staking out the nails or the marking the points. Being able to use AI in the sensor to always point to the right reflector, to point you to the right point, to not being misled by the number of reflective things on a construction site, which could be quite cluttered and quite busy. I think these are, for example, the use cases where you immediately want to have the results. These technologies at the edge get you to a greater ease of use in order to also having these specialists from the other industries using geospatial sensors and so enlarging basically the geospatial community.
Thank you, and thanks for weaving my question in there as well. Well done. So, thank you for the question. We had one right over here.
Do you think that there will be a paradigm shift in taking learnings from LLM models and thinking about a future of visual language models?
I'd say that's already happened. And so, like, if you think of what LLMs are doing, they're effectively translating text into, into embeddings, into the language of math, and we do that already visually. And I think what's interesting, because there's a long history in computer vision of doing that, but usually people were looking for, cats in a picture. I think what's unique to this space is you're looking for cats that are, actually the location of it, and actually having to use a full view shed that comes at it from many, many different angles and have to precisely locate that. And so that language has definitely been developed. And it's continuing to get improved more and more and more and more. And so I think maybe the next question on that is how to open that up to more people to be able to access that.
Okay, we had a question right here. Mike.
Hi, good morning. I'm Jeffrey Levine with NVIDIA. As you're putting, more sophisticated sensors that are collecting more data, how do I get real-time data from a remote location and take the data I need and transport that so someone can make a real-time decision?
We have sensors that oversample dramatically from 10 times what we're actually looking to persist and deliver. And so there's smart algorithms that are being implemented right in the sensor head or just on board the platform to reduce that data but not delete it, so that you can with one of our platforms, we're able to maintain and archive full resolution of that time of flight data from the collection. If we ever need to go back to it and produce some insanely high volume or highly detailed data set from a small area, we can do it. That's compressed, it's archived, put into cold storage or whatever. But the everything that we push through the processing chain is decimated kind of at the sensor head or on the platform. If that makes sense.
Colleague from Switzerland, Japan, Belgium, DC, Boulder. Thanks very much for all of you for traveling in, and thank you very much for the questions.